Today, we will be discussing about Cipher block chaining and the way it works. Cipher block chaining (CBC) was first created in 1976 by Ersam, Meyer, Smith and Tuckma. This mode is about adding XOR to each plaintext block to the ciphertext block that was previously produced. The result is then encrypted using the cipher algorithm in the usual way. As a result, every subsequent ciphertext block depends on the previous one, which creates a chaining effect. The first plaintext block is added XOR to a random initialization vector, commonly referred to as IV. The vector has the same size as a plaintext block. We will begin by using DES as an example for our block cipher. In this example, our plaintext will be 32 bytes. The entire plaintext will be separated into blocks of 8 bytes each. If the plaintext cannot be divided into 8 bytes equally, padding will be added to ensure each block are equal in size. We continue by looking in detail how each block is processed. An initialization vector is used because a previous block of text do not exist, as this is the first block in the text. IV is used to randomize the encryption. While it does not need to be secret, it must be unpredictable. The block of text is XOR with the IV before going through the DES encryption. For DES encryption, a key of 64-bit is required. The output from DES encryption will be the first cipher block. This cipher block will then be used in our encryption of the next block of plain text. The encryption for the second block is identical with the previous block. The only exception is that instead of an IV, the previous cipher block is used for XOR with the plain text block. The product of the XOR will then go through DES encryption, which produces another cipher block. Again, this block will be used in the next encryption. Again, the process of encryption is similar to the previous block. The process of encryption is again similar to the previous block. The output of DES encryption will not be used for encryption of another block, as this is the final block. After the encryption of each block has completed, the blocks are combined in order into a ciphertext. We then continue to look into the process of decryption in CBC. We continue to use DES as an example for our block cipher. In this example, our ciphertext will be 32 bytes. The entire ciphertext will be separated into blocks of 8 bytes each. The cipher block will first be decrypted using a 64-bit DES key. The output of decryption is then XOR with an initialization vector. Similar to the encryption example, IV is used because a previous block of text do not exist. The product of the resulting XOR will be our first plain text block. A copy of the first cipher block will be used for the decryption of the following cipher block. The decryption for the second block is identical with the previous block. The only exception is that instead of an IV, the previous cipher block is used for XOR with the output of the DES encryption. The product of the XOR will be our second plain block. Again, the process of decryption is similar to the previous block. The process of decryption is again similar to the previous block. The initial cipher block will not be used for decryption of the next block, as this is the final block. After the decryption of each block has completed, the blocks are combined in order into a plain text. Thank you for watching.